It's another math day here with teacher Jenny. Join me for another topic. This time, we are going to talk about the limits of piecewise functions and how we evaluate the limits of piecewise function. When you say piecewise function, it is a function in which there may be two or more functions inside that function with a specific domain. Just like this one, this is a piecewise function because your f of x contains only not one, not two, but three functions. And within that functions, we have a specific domain under that one. So we've got that one here. So this might be confusing if you really don't know how to figure out as to what will be the possible values that are considered on that particular domain. Because in evaluating our piecewise function, especially on the limits, we will not be using all of the functions, but we will be just choosing the function that our x fits in, or our x is included on that particular domain. So let us start evaluating our limit here. So we've got here the first one, limit of f of x as your x approaches to 2. With the negative symbol here, that means to say we have values are coming from the left side of 2. So if you try to look at this, we may draw a number line. If you are so confused as to what will be the values included here, we may draw a line and then the value, which is the reference, we have the number 2. And if you don't know how to distinguish between which one are the possible values? Is it gonna be on the left side of your 2 or right side of your 2? Then kindly look at this pointer here. This pointer will help you identify as to what will be the direction of the values considered on the domain. This is pointing to the right side. That means to say that the values of your x are found on the right side of 2. But we do not include 2 because we don't have an equal symbol here. So that means to say our 2 is a hollow and we are considering those values that are found on the right side of 2. That is moving towards positive infinity. So values could be 3 or within 2 and 3. So those are the possible values of the domain. Next domain here is we've got your x is in between the 0 and 2. Notice that x is in between the 0 and 2. That means to say that the included values here are going to be starting off with 0 and then with 2. Meaning to say it's going to be between the two values. Meaning we start with a 0. 0 is included because we've got an equal symbol in here. So that means to say that this should be a close one. We move towards our 2. This is also a closed one because we've got an equal symbol also on that one. So the values that we are considering are the values found in the middle, and so with your 0 and the 2. So those are your possible values of x on the second function. Next, we go to the third function. We've got a 0 on that one. Looking at the pointer of that symbol that is pointing to the left side, so that means to say that the values to be considered are going to be from 0. We do not include a 0 in here. We move towards the left side as per the direction of your symbol. So on the left side of 0, we've got negative 1. We've got negative 2. We also include the numbers in between those values included. So let's now go back to our finding the limit of the function f of x. So limit of f of x as your x approaches to coming from the left side. We locate the number 2 on our number line here. Which one got or contains the number 2 value? So which is with our first function, we've got the number 2 mentioned in here, and so with the second function. But then again, if you try to look at the symbol at the top of 2, that is a negative. That means to say it's coming from the left side of 2. Values will be moving towards 2, coming from the left side. So if you try to look at the first one, this is the number 2, but the values are found on the right side of 2. So that means to say, if you wanted to approach 2, these values are coming from the right side. So that means to say, we do not use the first function. Instead, we are going to use the second function because if you try to look at this, values are coming from the left side of your 2. So, that means we are going to evaluate the limit of the second function, which is the x plus 1, as your x approaches 2 coming from the left side. So evaluating that one, that means to say we are going to simply substitute the value of 2 there. So we've got 2 plus 1, that is equal to 3. So our limit of our function there is 3. Next, let's go to limit of f of x as your x approaches 2 with a positive on the top. That means to say that the values are coming from the right side of 2. So if you try to look at this, we've got the number 2 here and the values considered are on the right side of 2. So that means to say that we are to refer to the first function. So this is now equal to the limit of your 2x minus 1 as your x approaches 2 coming from the right side. So this is now equal to 2 times your x, which is 2, minus 1. So this is now equal to 2 times 2, that's 4, minus 1. So this is equal to 3. Okay, now, looking at that one, we've got the same value on the left side and right side limit. So that means to say that once you are going to look for the limit of f of x as your x approaches to 2, you know now the answer. That is equal to 3 because again, your left hand limit and the right hand limit are the same. So our limit exists and that is the value which is 3. So let us now try to look at the next one. So once we have there limit of f of x as your x approaches 0 coming from the left side, so we are to pick the right function here. So 0 coming from the left side. So once again, you may draw the number line. So this is now 2. That is pointing towards your right side. So these are the values considered in here except for 2. Next, on the number line here, we've got a 0 and a 2. The numbers in between that one and those numbers are included as the values of x. Next, we've got here an x, which is 0. And then the sign there is pointing to the left side. So that means to say that the values included are to the left of 0 except your 0. So let us now go back. So this is now 0 coming from the left side, or your x values are coming from the left side of 0. So if you try to look at the direction there, we've got a 0 from the left side on your third function. So again, zeros from the left side of zeros, that's our third function. Because the second function, although it's mentioned here that we've got a 0, but that is with the right side of 0. Okay, so your second function is not the one, but what we are looking for is the third function because we've got that as the left side values. So we are to use the limit of x squared plus 1 as your x approaches 0 coming from the left side. That will be equal to, we substitute 0 on x, so we square that plus 1. This is equal to 0 plus 1, that is 1. We go for the second one. We've got the limit of f of x as your x approaches 0 coming from the right side. So this is now equal to the limit of, we are going to look for the function that satisfies that one, and this one is the second function because that is with a 0 coming from the right side. I mean, not zeros coming from the right side, but the values of zeros. The values of your x, which are coming from the right side of 0. So we will be using the second function, which is x plus 1, as your x approaches 0, coming from the right side. So this is equal to, we substitute the value for your x, which is a 0, plus 1, that is equal to 1. Notice they have the same value, so that means that the limit exists, and that is equal to 1. Okay, the next example here is a piecewise function in which the function here has a 3 subfunctions, and then we are going to look for the limit of f of x as x approaches negative 4. So before we answer that one, let us find first our limit of the function f of x as your x approaches negative 4 coming from the left side. So getting to know the values of your domains here, we have negative 4 for this. This is pointing to the left side, so that means to say that the values are, we don't include negative 4, but the values towards the left side of negative 4, that will be included. On the second function, we have the domains, which is negative 4, which is part of that. And then 2 also is part of the values of x, including the ones in the middle. On the third one, we've got 2 here. And then 2, we've got x greater than 2. So that means to say, if you try to look at that, that is pointing towards the right side, but we don't include a 2 here. But the values are to the right of 2 until infinity. So checking up, we've got limit of your function, f of x, as x approaches negative 4 coming from the left side. So we are basically looking for the first function because here, we've got the negative 4 and the values included here are towards the left side of negative 4. So basically, when you say coming from the left side of negative 4, these are the values that we're including. So approaching to the negative 4 from the left side. So we have now the limit of your square root of 5 minus x as x approaches negative 4. This time we are going to substitute. So we've got square root of 5 minus our x is negative 4. This is equal to the square root of 9. This is equal to 3. Let's try to check if we have a limit of f of x as your x approaches to negative 4 coming from the right side is still 3. So this is now equal to, now take note this is coming from the right side of negative 4. So if you try to look at the domain here, this is the one which has the values that are coming from the right side of negative 4. So basically we're going to use the second function. So we have here the limit of your x squared minus 5 as your x approaches negative 4 coming from the right side. So this is now substituting, we've got negative 4 squared minus 5. This is now 16 because negative 4 times negative 4 is 16 minus 5. This is equal to 11. Now answering this question, limit of f of x as your x approaches negative 4, this is equal to a D and E because your limits from the left side and right side are not the same. So the limits here does not exist. So that is how you evaluate the limits of your piecewise function. So I hope that you learned something.